Hey everybody, welcome back to the channel Stats with Ahili. This is Ahili Bhattacharya, your stats buddy, and today we are going to cover bivariate data. This video is going to be very special because as you can see my camera is on and it will be on throughout the video, okay? So yeah, let's get started. Let's start with a very intriguing question or maybe a real talk. Have you ever noticed how some things just go together, like ice cream and sunny days or study time and good grades? Today, we're exploring exactly that, but with data. We are diving into the world full of bivariate data. See, grab my notes and let's make sense of how variables work together. I promise it's going to be way more fun than it sounds, okay? So, what exactly is bivariate data? Well, bi means two and variate means variable. So, we are just looking at two things together. Instead of just looking at height or weight alone, we look at them as a pair, height, weight for each person. Think of it like this: we are playing matchmaker for variables. We want to see if x and y make a good pair. Are they moving together, going in opposite directions, or just doing their own thing? Now, how do we visualize these data pairs? We throw them a party on a graph. This is what we call a scatter plot or a scatter diagram, as you can see. Each data pair gets to be a dot on our graph. When we plot all of them, we get this beautiful scatter of points that tell us a story. Let's come to the next page. Yes. The uses. The magic of scatter plots is they help us answer two big questions. First, what is the nature of the relationship? First, C helps in studying the nature of the relationships between the variables. Like, are they besties who always move together or enemies who move apart? Second, measures the extent or degree of the relationship, which is how strong is their friendship? Are they inseparable or just casual acquaintances? Okay? See, this is the scatter diagram as I have drawn here. Now let's give this relationship a name. This is what we call correlation. There are three types of correlation: positive, negative, and zero correlation. First, positive. When I go up, you go up, like study time and grades. Negative correlation. When I go up, you go down, like phone time and productivity. Zero correlation. We're doing our own thing, like your shoe size and your favorite pizza topping. See, this is a diagram for positively correlated. And next page is we have our negative correlation diagram. This is zero correlation or no correlation diagram. Okay. See, the key is looking at the overall trend. We are not worried about every single dot, just the general direction they're heading. Okay. But how do we put a number to this relationship y? That's where covariance comes in. Let me say the formula. Covariance is equal to 1 by n summation xi minus yi minus x bar y bar. I running from 1 to n. Okay. See, here's a cute way to think about it. For each data point, if we see x and y both above average, it will be positive. Both below average, it will be again positive. Or if one is high while the other is low, it will be negative. See, they're usually in sync. When they're usually in sync, we get positive covariance. If they're out of sync, they're negative covariance. If it's random, it cancels out to zero. Now, let's come to the properties, which are the rules of the covariance game. These properties are like cheat codes for solving problems. Property number one: covariance AX is equal to 0, where A is constant. A constant cannot co-vary with anything, okay? It's like trying to measure how your height changes with a number 7. It doesn't, right? So, yeah. Coming to property number two, the covariance of something with itself is just its variance. It's the ultimate self love story. All right. Now, coming to property number three. See, this property is a little fancy, it looks a little weird, but we can solve it by the distributive property of covariance. See, I cannot help you with here anything because in property number 3, 4, and 5, you need to write it down in your pen and with your pen and copy, okay? And you need to memorize it. Not memorize it, you need to learn it. You do not have to memorize it because this is just an algebraic sum. That's all. So property number 4 is basically the addition of variance, and property number 5 is the subtraction of it. That's it. Okay. You need to please write it down in your notes and study for understanding this. Okay. Now that's the end of our session basically. Let's do a quick recap before we end the session. We learned how to visualize data pairs with scatter plots, how to describe relationships with correlation, how to measure the vibe with covariance, and the cool properties that help us calculate everything. But guess what? Covariance has a little secret. Its units are kind of weird. In our next video, we'll meet the superstar that fixes this, the correlation coefficient. So, yes, that is the end of our session. If you enjoyed this video, please share, like, and subscribe. And yes, we can do something like leave in the comment section what is your favorite data pair. For example, mine is tea with productivity. Okay, what is yours? Let me know in the comments. And yes, by end of the session, study hard and keep trying.